To understand why real-time and short response time was important, it is necessary to understand the basic function of such a lab system, so here a short explanation. Here you see a picture of the HP 1000M R33 Labka system from '79, illustrating the different main functions. On the left you see the Greiner GSA 2D analyze machine. The display file was a file on the HP 1000 system where data, that is analyzed results from the GSA, was stored. When acquiring the lab computer in '78, emphasis was placed on the instrument real-time problems, because laboratory instrument online connection was not so common in the '70s. If an instrument had a serial 232C output, it was lucky. And bidirectional interface, that is where the computer both receives results and tells the instrument which analyze it has to perform, that was rare. The Greiner 2D here, which was a very large and expensive analyze machine with conveyor belts and many dispensers, this instrument got this bidirectional interface in connection with the HP 1000 project. The system here worked completely in real time. That is, all functions worked simultaneously with short response time, also during the frequent selected prints to the clinical department. On the right is shown keying in the requisition data. Note the sample form with labels, which were used to mark the sample tube containing the sample material to be examined. I will return to that later. The storage space for the analyzed result was limited to approximately 20,000, equal to a time period of approximately 1 month. There was no big database. With the new HP 1000 A-series system and the RTE update, the Labka system got order entry via OMR readers, and the archive was later to expand it to more than 20 million analytical results, and many extra functions were added. OMR reading already came in '84. Entry of OMR requisition via the OMR reader can be seen here. There could be several OMR readers on a system. The system also got cumulative printout, which you see here. It came in '88. Then the doctor could see the patient's many analyzed results in a manageable form, always sorted correctly in time. The new result is bolded. If corrected, data is marked with an R and bolded. There was footnotes, reference data, etc., helping the doctor to get an overview over the patient's data as a function of time. More about the growth of the entire eye system later. First, a little about of the OMR sample order form and a small video demonstrating conditions around taking sample from the patient. In the laboratory, sample material to be analyzed was taken from the patient in a suitable container, which has to be marked with a label, a barcode label. And at the same time, several data has to be registered, including which analyses had to be carried out on the material in the various different containers, called the test tubes. A sample order form could be used for this purpose, shown here as an OMR readable form. OMR forms were introduced around '84. It consists of 2 layers separated by carbon copy paper, so when you marked the desired analyses on the front side, the marks were automatically placed on page 2 on the corresponding barcode labels. OMR data was quickly loaded into a file via the OMR reader. A little later picked up on the screen, and further data could be added. As mentioned before, several OMR readers could be connected to the HP1000 system. The important registration identification numbers can be seen here beside the sampling time and the department. Now I will key in my Labka user code. Now I'm in the system and I get this menu. But I prefer the next menu on the next page, so I'll activate this function here. This menu illustrates the main functions in the system. You see in the requisition here up here, the search procedure, correction, result input, reporting. But I will concentrate on requisition, so I will activate this function key here. Here you have the requisition formula. You can see that the system has positioned the cursor in the person number registration field, so I'll start by keying in that number, 09013711. Okay. And I shall also add the requisition number. As you remember, this is a number on the requisition and also on the sample containers. So I'll put that number in 77000971. And I should also tell the system when was the sample taken. It had already the date, so I just need to put in the time. That is 12. And then I send this information to the system. Now you can see it fetched the name on this patient. It's the Daisy doc. It's taken from the name database. And then it positioned the cursor in the requester field. So I'll put that number in 2408 and send the information again. Now it positioned the cursor in the analysis mnemonic field. So I'll type in name on analysis. That's the CRP. And I set a cross here. That means it is a routine analysis. Then I use the albumin also here, and the CREA also X here. And I will now send the information to the system. The requisition is now in the system. That means it's available for all the instrument. If they take a look up, they can find this requisition and it knows which analysis it has to perform on that sample tube. But I have no instrument here, so I have to enter some of the results manually. And there are several ways to do that. I will do it by keying in the requisition number in the control field up here. So I do 770071 and send it to the system. The system now finds the requisition and make an input picture for just these three analyses. So that's the CRP, that could be 5. And the albumin, that could be about 70. That's a little high, 50. And then a CREA, 100. So I send this information to the system. So now the result is in the system. But let us see how the requisition and the result, how does it look. So I press the SG switch over here. I get the number transferred and I press the send key. And here you see the requisition with all the results. A little pause. Then we will continue with a short demo about corrections in the system. Corrections require flexibility. I will assume that the situation around the patient have changed so that the department wants us to perform another test on the sample material we have here. But before I talk about corrections, I would like to talk a little about what we call stat analysis and handling codes. In the ideal world, the process regarding lab should be very fast. You should have fast sampling, fast analysis, fast reporting. But the amount of volume and other circumstances may force the laboratory to divide the processes into groups. For example, routine analysis and acute analysis called stat analysis. You could mark the routine analysis with an X or the stat analysis with an H, and then handle the samples and the information according to this marking. Furthermore, with regard to organization of the lab, you could divide the laboratory into what you call a routine lab and an acute stat lab. As I said before, the process can be divided into three: sampling, analyzing, reporting. Reporting is perhaps the procedure which is the most easiest to optimize. For example, a routine resource you can wait until all the results for that requisition has arrived and then print it out. For stat analyze, you can do it more frequently, not waiting for all the other results for that requisition. You can have more handling code than just the two I have mentioned, and you can have this different printing parameter depending on which department and also what time you are printing the results. Regarding analyzing, you can put the sample in front within the analyzing queue. But regarding sampling, you can try to organize, but you need a larger staff. Change. If change, the action could be as follows. You have to inform the analyzing machine about the new order. But you also have to ensure that the sample material arrive to the right instruments. And you have to ensure that the reporting system is reflecting the change so that the end user can see what have been changed. If the requisition has arrived earlier and nothing has been done, the requisition you just changes is no problem. But if the process is going on, that means there can have been some samples and there can have been some analysis and some of the results might even have been reported. Then the situation is more complex. You can, of course, just make a new order, a complete new order. But then you have to make a new sample order and you have to make a new sample on the patient. And that is not nice if you have to take sample on small children, as you see here. It's not so nice to take sample on small children. It is not so nice to take sample on small children. The children might be smaller than this one, so it will be appropriate to make the analysis on the sample you already have, and that is also much more economical. So it is in this slide you have to see the next demonstration on the system. The user can on the form see which analysis has been ordered, if there is any result already, and thus the user can get an idea of where is the sample, is the lab the user has to go and find it. Furthermore, the user can by several X get the result input form so they can put in the result if they have it already, so they can do it all in the same form if they are in a little stat lab. If reporting has occurred already on this requisition, the information will be marked. As you can see, the reporting is one of the more demanding functions both in the lab and in the IT system. But it is important that it is there. But let us now go to the demo on the system, and please notice that the information I have told you about here is present in the form. Okay, let's go. Can I do that? Yes, I just press this function here. So, and I get the number transferred, activate send. And here you see the requisition here, and it's blinking in these three fields. That means there is a result on them. But I should request a hemoglobin. So I write HB here, and I should request this as a stat analyze, and that's H. If I have a result already, I could make a cross in this field up here. If I don't have it, I just send it. But I think I have it already. I've just made it. So I just set cross up here. So now it said this is a more sensitive procedure. So you have to do something extra, put an RG in the control field. So I do that. So I can just put it in 7.2 and send it. So if I want to look at the requisition with results, I press the SG here. Once more. And here I have the requisition with the new results hemoglobin as a stat analysis. I can of course also search via the person registration number. If I want to do that, I just press SP here. See the field shift from here to here, and I then press return. And I get the same information, but that is because this is the youngest one. There are 19 older here. So if I will look at the older, I press this function key here, and I can go back in time, and so on. If I want to write it over out on the printer, I can just write S3 up here and it come out on the printer. But I can also make a cumulated search. How do I do that? I just write SK accumulated search. But here I will take another patient where I have some nice data. There's 21 0 3 0 9 5 4 K, and I press enter, and here it comes. It's from Andreas dog. Previously it was the Daisy dog. And here you can see all the analysis on this patient listed in time order, and the reference is allowed here. If I want to write it on the printer, I just write S3, and I should write an A also because I want all the columns. Otherwise I have to specify the columns I want the time interval. So I will send that on. And now the printer is printing out the cumulated report. I can hear the printer in the background. Here we have the printout for Andrea dog. This was the end of this little demo. So I will end the session by logging out by pressing this key here, Slut. Hi. A friend of mine remarked after watching the videos about the HP1000 and the Labka system that I was so impressed about the HP1000 system and the development of Labka. But many of the YouTube users would perhaps not be so impressed because nowadays we have so much advanced IT. I think it is right here, but it made me expand the chapter on Labka with demos, comments, etc., as well as these remarks in order to see the development in a more historical or general light. But skip here the next 4 minutes if historical development is of no interest. I do not want to go back to Aristotle. His views on natural science, however as special they were used up to the year 1800. Perhaps because he was so extraordinarily clever in other areas. But I am now taking a big leap forward, and if we stick to the laboratory sector, I can state that in 1860, 306 analyses were carried out on the University Hospital in Copenhagen. But scientifically, development has already taken off. But I do not have the prerequisites to describe scientific development. But I can, for example, state that before 1960, the lab technician used approximately 30% of the work in the laboratory for administrative work, including calculation work. That was before the microprocessor came out. In the 60s and 70s, the number of chemical analyzers in the hospital increased dramatically, at the same time as the development in automation grew. In the 60s and 70s, the equipment became more and more advanced, as mentioned also in Chapter A. It was sometimes used in a simple form, for example paper tape and punch cards, where you got files with requisition in data in one file and result data in another file, and then you merged together before printing. However, this contributed to being able to handle large productions. On basis of scientific development, chemical chemists in the 60s had already further developed systems so that the chemistry could be described more scientifically correctly. I think here on the analysis name as you see here. On basis of all this scientific development, this clinical compendium was published in 1979. It was in the same year as the HP1000 artery-free Labka system was put into operation. You now have an unbroken IT lab line from requisition, analyze, instrument, storage, reporting, the correct scientifically analysis name. For example, the introduction of the Labka IT system at the ML laboratory in Copenhagen in 1979. That is to go from manual work procedure to that of the IT Labka system. This resulted, based on the ML lab information, the number of stat analyzers falling by 50%. The reason for this was better service, that is, faster response time for the common analysis. Since stat analyses were significantly more expensive than the regular analysis, this is in addition to the better service provided significantly resource savings. A big leap forward was also the Cumulated Answers in 1988. In a later video you will see that on just one HP1000 you could print from 10,000 to 20,000 new responses in one day. Consider that the previous such answers were transferred from one simple piece of paper into a laboratory chart so that the doctor could get an overview over the patient's data as a function of time. Cumulated Answer, a tremendous labour saver, a very, very, very large reduction of transfer errors. So of course I was impressed, as my friend mentioned, about the HP 1000 and Labka. The next step with the HP 1000 was to connect the clinical department PC's terminals to the HP 1000 Labka system. It was called the Labka Hospital Package, or LSP. That was in 1998. There were about 2,000 PCs connected to a single HP 1000 with 4,500 users. In all, 37,000 users in total, as you can see here. I have only planned to talk a little about the LSP later. Also, in LSP we had a focus on flexibility and real time, and I have very nice instructive LSP videos from '98. More about the Labka system. You can follow the guidelines written here. It is a much more comprehensive description of the Labka system.